let's start the next slide. So, in this slide, I'll explain the definition of the refrigeration. So, what is refrigeration? The refrigeration is defined as the process of achieving and the maintaining a temperature below that of surrounding. Means that you are maintaining the temperature below surrounding. So here I mention the achieving and the maintaining. What is that meaning? Before starting the refrigerator, the refrigerating space temperature and the surrounding temperature are same. After starting, then you are starting the refrigerator, you are supplying the electric, means you are giving the work to the refrigerator. In that case, when you supply the work, then you are achieving the low temperature that of surrounding. After that, you are opening and closing the refrigerator door. So at that time, some heat will transfer to the refrigerating space. Again, you have to maintain the below temperature of surrounding. So clearly I mention here achieving, first you are achieving the low temperature, again you are maintain that low temperature continuously throughout the cycle. So this is the definition of the refrigeration. Refrigeration means it is the process of achieving and the maintaining the temperature below that of surrounding. Another way also we can define the refrigeration. The transfer of heat from low temperature region to high temperature region, one requires special device called refrigerator. So this is according the Clausius statement. Okay, you are defined the refrigerator accordingly the Clausius statement. Then the refrigerator are the cyclic device and the working fluid used in the refrigeration cycle are called refrigerant. Actually, the refrigerant is the heat carrying source or heat carrying medium. The refrigerant extracts the heat from the evaporator and that heat is rejected to the surrounding by the help of condenser. So here refrigerant is the heat carrying medium. In the air refrigeration cycle, the air is used as a refrigerant because it is availability of free of cost. Another also advantage in the air refrigeration cycle, by chance, by accident, if the refrigerant leak and human will be inhaled, that will not a problem. Okay, because air is not a toxic gas. If you are using some toxic gas as a refrigerant, by accident it will be leak, then it will harmful to the human being. For that reason, you are using the air as a refrigerant in the air refrigeration cycle. But the main disadvantage in the air refrigeration cycle, the air is the low heat carrying capacity. Next, the unit of refrigeration. All of you know that when you are going to purchase some vegetable, at that time you are telling give 2 kg of potatoes or 2 kg of onion. Like that, when you are going to purchase the refrigerator, you have to use the unit. So in the unit of the refrigeration, that is the ton of refrigeration. So the practical unit of the refrigeration is expressed in the ton of refrigeration. So you have to define what is ton of refrigeration. The ton of refrigeration is the quantity of heat removed from 1 ton of water at 0 degrees Celsius to convert ice at 0 degrees Celsius in 24 hours. Now you observe here the water temperature is 0 degree Celsius and the ice temperature is at 0 degree Celsius. But the phase is converted from water to ice. You have to remember, when you are extracting or removing the energy, when you are extracting or remove the heat from the source, then that source temperature will be decreased. Again I am telling, if you are extracting the heat from the space temperature will be decreased. If you are supplying the heat to the space temperature will be increased. So here you are removing the heat from the space. So the water is converted to the ice. So what is the ton of refrigeration? The ton of refrigeration is the quantity of heat removed from 1 ton of water at 0 degree Celsius to ice at 0 degree Celsius in 24 hours. So this is the latent heat. Why? Because phase is changed but temperature is constant. So the latent heat of ice is 335 kilojoule of kg. Mathematically, we can write 1 ton of refrigeration is equal to 1000 into 335 kilojoule per kg in 24 hours. Now I am converting the hours to minute in the next step. So here 1000 into 335 into 24 into 60. So if you calculate here, you will get 232.6 kilojoule per minute. If you want to convert into kilowatt, then you have to again multiply 60 at the bottom. So here 1000 into 335 by 24 into 60 into again 60, you have to divide. Then you will get 3.8 kilowatt. But in the actual practice, 1 ton of refrigeration is taken as 210 kg per minute or 3.5 kilowatt, because accordingly US 1 ton is equal to 2000 pound is equal to 907.185. So if you calculate in this method, you will get 210 kg per minute or 3.5 kilowatt. Let's go to next slide. Now I am defining the definition of the C.O.P. The C.O.P means the coefficient of performance. When all of you know that when you are calculating performance of the engine, at that time you are telling the efficiency, and when you are calculating the performance of a device, you are telling coefficient of performance. Both case the same. When you are calculating the performance of any device, that is the output by input. But in the engine case, the output is the work and the input is the heat. But in the refrigerator case, here the input is the work and the output is the heat. Let's define what is C.O.P. The C.O.P is defined as the ratio of heat extract in the refrigerator to the work done on the refrigerant. Mathematically, we can write C.O.P is equal to Q by W. So what is Q? The Q is the amount of heat extract in the refrigerator and W is the amount of work done. So if you calculate per unit mass, then the coefficient of performance is equal to small q by small w. Second note, the COP is the reciprocal of the engine. How? Just now I told the COP and the efficiency both are same when both the COP and the efficiency is the output by input. But what is the difference between them? The COP, in the COP, the input is the work and the output is the heat. But in the efficiency, when you are calculate the efficiency, the output is the work and input is the heat. That for that reason, COP is the reciprocal of the heat engine. So the value of COP is always greater than 1 unit. All of you know that when you are calculating the efficiency of the engine, okay, at that time always the efficiency is less than 1 unit. But when you are calculate the latter will you observe, when you calculate the COP value is always greater than 1 unit.